Hi everyone, I am Prajwal from SVC Engineering College, Bangalore. My branch is CSE Data Science of first year and the first SEM. Yes, today I am here to discuss about the point-to-point communication of optical fibers in physics subject. Now let's move to the topic point-to-point communication in optical fibers. This presentation explores the fundamental of optical fibers communication and its application in point-to-point communication system, and it divides the advantages, challenges and future trends in this technology. The next point is introduction to the optical fiber communication. It has two subpoints called history and evolution and key applications. In history and evolution, the revolution telecommunication, it has a technology that utilizes pulses to transmit data over long distance with high bandwidth and minimal signal degradation. And the another point, key application, is this technology is widely used in internet connectivity, long distance phone lines, data center and high speed network. That's about the second point, fundamentals of optical fibers. Then what are the fundamentals of optical fibers? Core, buffer and another one is cladding. Then what is core? Core is nothing but the center part of the fiber through the light propagates is called core, and the buffer is a coating of the shield that fiber from the external damage is called buffer, and the another is cladding. The cladding is nothing but the surround the core with a lower refractive and index, ensuring the total internal reflection of light within the core is called cladding. Propagation of light in optical fiber. It has two subpoints, the called the total internal reflection and the modes of the propagation. Then what is the meaning of total internal reflection? It is the light travels through the fiber by repeatedly reflecting off the cladding is called total internal reflection. The another point is mode of propagation. The light can propagate in different modes depending on the fiber through a wavelength is called mode of propagation. The next point is fiber optic transmitter. As shown in the pyramid, the first point is source. Then what is source? The laser of the light generates light pulses. The second point is modulator. Modulator the light signal with data. And the third point is coupler. Coupler the modulates lights into the fiber. It is called coupler optic receivers. As shown in the slide, there are three steps. First is photodetector, amplifier, decodes. Photodetector converts optical signals back to electrical signals. The another amplifier the received signals. The decodes demodulates and decodes the data. The next point is point-to-point optic fiber transmission. It has three subpoints called transmitter. Transmitter is encodes data into light pulses. The another point is fiber cable. Fiber cable transmits the light pulses. The last point is receiver. It decodes the light pulses back into data. The next point is factors affecting point-to-point communication. The first point has attenuation, the second point has dispersion, the third point has noise. The first point attenuation, it signals the loss over distance. The second point dispersion, signals spreading over time. The third point noise, the unwanted signals interfering with data. This about the point. Advantages of point-to-point optic fibers. Let me tell you, it has the 4 points. The first point is high bandwidth. The second point is low attenuation. The third point is immunity to interference. The last point is security. The first point, high bandwidth, has supports to massive data transfer rate. The second point, low attenuation, minimal signals lose over long distance. The third point, immunity to interference, it has the resistance to electromagnetic interference. The last point, security, difficult to tap into or intercept the signals. Now I am going to give the conclusion. The conclusion is future is optical fibers technology includes higher data rates, long distance and improve the network reliability.